These are the forces you will encounter in class. Applied force is a push or pull. Applied force only exists if you are constantly pushing or pulling an object, or lifting an object, or pushing an object down. So if I lift a bag, that applied force is upward to lift that bag. However, if I have a ball and I throw it in the air, once I release that ball, there is no applied force. We may use the following symbols for applied force: F, FA, FP, F of X, any of those. Weight is the force of gravity on an object. It is abbreviated by F subscript G or W. It is always perpendicular to the earth. So that means if I have an object and it's on earth and the earth is the ground, my force vector for weight is perpendicular to the earth. Weight is defined as mass times gravity, or W is equal to mg, or you could also use F subscript G equals to mg. Tensions occur for strings and ropes. We assume when we have tension, the strings and ropes are massless, and all the force along that rope and string is constant, so same force. The tension is always along the string or rope, and it's usually abbreviated with a capital T, but you could also use F. Normal, abbreviated N or F subscript N, is due to a surface. If there is no surface, there is no normal. Normal is always perpendicular to the surface. So if I have an object on the ground, and this is my ground, my weight is perpendicular to the earth. So I label that F subscript G or W. Normal is perpendicular to the surface. This is my surface, so it must be perpendicular. Something on a ramp, the weight is going to be perpendicular to the earth because it's on the ground on an incline. So that's F subscript G. The normal is going to be perpendicular to the surface, so it's going to go at an angle, N. So if this is my wall and I have a book on the wall, this is my surface, so normal is going to be perpendicular. It's going to push it away. And my weight, since it's on the wall, this is my ground, so it's perpendicular to the ground. The fifth force is called friction. Friction can be written as F subscript F, a cursive F, or F subscript S, S subscript K. Friction opposes motion. There are two types of friction we will discuss in class. The first one is called static friction. Static friction is usually labeled F subscript S. This is when objects are at rest or right before it moves. Sliding or kinetic friction, which is labeled F subscript K, is when an object is in motion. If I look at my plot, which is friction versus normal, you will notice this portion, the initial portion of the graph, is linear. So what that means is as friction increases, the normal or the weight here will increase. When it reaches here, this is my maximum static friction. As soon as an object starts moving, it will decrease, and this will become kinetic or sliding friction. If you notice, when you push an object, a heavy object, initially it is very difficult to start it to move because you need to reach that maximum static friction. But once you get it starting to move, you have kinetic friction and it's a lot easier to move. The general formula for friction is F is equal to mu n, in which F is friction. It could be static or kinetic. Mu is known as the coefficient of friction. And if it's mu s, this is static coefficient. If it's mu k, then this is sliding or kinetic friction. So if I look at my graph, if you notice, static friction maximum is greater than kinetic friction. So that means mu s, the coefficient of static friction, is greater than mu k, the sliding or kinetic friction. A free body diagram, or FBD, is drawing with only the forces directly on the object. To understand the free body diagram drawings, we need to understand the 5 forces that we just discussed. So if I have an object on the ground and we say it has weight because it's on Earth and this is on the ground, my weight is going to be perpendicular to the Earth. And it could be a W or F subscript G, because this is my ground. Since it's touching a surface, it's going to have a normal perpendicular to the ground. If I say I push the object constantly to the right, then it's going to have an applied force to the right because the object is moving to the right. If the surface is rough, it's going to have a frictional force in the opposite direction of the motion. And so this is my frictional force. So this is a free body diagram. Once you draw a correct free body diagram, we could write our equations to solve for our forces. In class, we discussed 3 generic formulas that you need to memorize. F net, Newton's second law of motion, is mass times acceleration. Friction is equal to mu n, coefficient of friction, times the normal. And weight, W, is equal to mass times gravity. Every single equation will be derived from your free body diagram and these 3 equations. For the unknown forces, we need to write a summation equation in the F direction and a summation equation in the X direction. The reason we have to do the X and Y separately is because force is a vector, and we can only add vectors if they are parallel. For this picture, my Fy is in the vertical direction, just like in math, and the vectors in the vertical direction, if you look at it, is N and W, or normal and weight. In general, I'm going to make going up positive, so N is positive. If you look at my weight, it is going in the opposite direction, so we're going to account for direction by already putting in minus W, or minus FG. This is equal to MA. When I write a summation FY equation, what I'm writing is a F net equation in the Y direction. And if you notice, F net is equal to MA. So this is why N minus W equals to MA. Procedure and write a F net equation in the FX direction, or the horizontal direction. The direction that we move in, we want to make positive. So FA is going to be positive because the object is moving to the right, minus friction, because friction is going in the opposite direction. This is equal to MA. So all of your equations that you're going to write, you're going to draw a free body diagram and write a summation of the Fy and Fx. And then after that, it's just algebra. You're going to solve for one variable and plug in to another. Number 4, we did in class. So this one, we don't have to draw a free body diagram because we're just looking for weight. So weight we know is W is equal to mass times gravity. So mass is what? 0.113 kilograms times gravity, which is 9.8 meters per second squared. So multiply it. And if you multiply it correctly, you get around 1.1074 newtons. Remember, a kilogram times a meter per second square equals a newton. That is the proper units. A stone is on a table. The first thing you need to do is draw a free body diagram. Pause the video, draw the free body diagram, and check your answer. So we have a table, and there is a stone. Remember, a free body diagram are only the forces directly on the object. In this case, this is the stone. Since the object is on Earth, we're going to have weight perpendicular to the Earth. We're going to have a normal because it's on the surface, perpendicular to the surface. So the table is going to push it up. There are no other vectors because there's no friction, it's not being pushed, it's not being pulled. So all the vectors are in the y direction. So I need to write a sum of Fy equation. So sum of Fy in the vertical direction, N is going up, so we're going to make it positive. W, or weight, is going in the opposite direction, minus, I already account for direction by putting the minus in. W equals to MA. This MA is equal to 0 for the following reason. We stated in class, acceleration is 0 meters per second squared when it's at rest or when it's traveling at constant velocity. We know this is at rest because it's stated it is at rest. So N minus W is equal to 0. I'm going to move the W to the other side by adding W to both sides. The W cancels out, so N is equal to weight. And what is weight? The weight of the stone is 20 newtons. So the force the table exerts on the stone is 20 newtons upwards. pause the video, read the question, and draw a free body diagram. Check your answers. So if you drew your picture correctly, you should have 4 forces for your free body diagram. If you drew your free body diagram correctly, you should have 4 forces on your object. So we have a block. It's on a table, so it's on a surface. So we have a normal perpendicular to the surface. We have weight because it's on Earth. So there's a pull of gravity perpendicular to the Earth. You have an applied force because it says you must exert a force of 14 to keep it going. So there's a force. We're going to make it move to the right. You can move it to the left. It really doesn't matter. And since they said there is traveling at a constant velocity, there must be an opposing force. But if you read part A, there is also coefficient of sliding friction. So that means there has to be friction in the opposite direction, F. So here, we need to write a sum of Fy and a sum of Fx because they're going in 2 different directions. So if I write my sum of Fy, my vertical forces are N going up minus weight going down equals to MA. So if I look at my free body diagram, do you see how the N and the W are in the vertical direction? My MA is going to be 0 because it's not moving in the vertical direction. So like before, we're going to add a W to both sides. So N is equal to W. In the X direction, we have 2 vectors going in the X direction too. Remember, we said the direction we move in, we want to make positive. Since it's going to the right direction, which is FA, FA is going to be positive minus friction, which is going in the opposite direction. This is equal to MA. MA is equal to 0 because this is moving at a constant velocity. Remember, acceleration is 0 when it's at rest or constant velocity. Since we are looking for the coefficient of sliding friction, we need to solve for friction. Since FA minus F is equal to 0, I can add friction to each side. That crosses out, so friction is equal to FA. Friction in the previous slide is mu N. So I'm going to substitute in for friction, which is mu N. This is equal to FA. We're looking for the coefficient of sliding friction, which is mu. So I need to divide by normal on both sides. So mu is equal to FA over N. What is N equal to? Do you see how we solve for N over here on top? So I'm going to substitute that in. So FA over W is equal to mu. It says you must exert a force of 14 newtons. 14 newtons, that is the force you are applying. So that's your applied force. To keep the 40 Newton block, that is your weight. Divide the 2 and you should get 0.35. So if I place a 20 Newton brick on place of the block, what's going to happen is it's going to change the frictional force. Why? The frictional force is dependent on weight. So what happens is my free body diagram will have the weight of the block plus the brick. So when I rearrange this and write the equation, this was now the weight of the block plus the brick. And so N is now the block plus the brick. So when I solve for friction, which is friction is equal to mu N, this is going to equal to mu W, which is the brick plus the block. So if I plug this in, this is 0.35 times block's mass was 40 newtons plus 20 newtons of the brick. This is going to, which will equal to 21 newtons for the force of friction. So now I could resubstitute in. Remember, the sum of Fx is equal to Fa minus friction equals to Ma. Remember, Ma was equal to 0. So when I rearranged it right here, friction equal to Fa, and we wanted to move at a constant velocity. And what was friction? 21 newtons. So in order for it to move at a constant velocity with the new added weight, my applied force has to be at least 21 newtons. Pause the video, read the question, draw the free body diagram, and write the equations. And check your answers. So if you drew your free body diagram correctly, you should only have 3 forces on your object. We're going to have weight perpendicular to the earth because gravity is present. We're going to have normal perpendicular to the surface because this object is on a surface. And we are going to have frictional force. If the object is moving to the right, the frictional force must oppose the motion. So it's going to go to the left. The reason there is no applied force is it's friction that is slowing the object down. If there was no frictional force, the object would continue on without stopping. So first, we're going to write it sum of Fx and a sum of Fy. In the y direction, we only have 2 vectors, normal and weight. So the sum of Fy, and we're going to make going up positive, is N minus W. It is minus W because weight is going in the opposite direction. This is equal to MA. MA is equal to 0 because the tires are not traveling in a vertical direction. So that tells you that if I add weight to both sides, N is equal to weight. Now I'm going to write a Fx equation. In the x direction, I only have 1 vector. So the sum of Fx is equal to friction. Remember, you want to make the direction you're moving positive. Since it's moving to the positive direction, right, friction is going to be negative F equals to MA. First question asks us to find the size and direction of the force of friction. Since the coefficient of friction is given, we could use the generic formula for force of friction. Friction is equal to mu N. The coefficient of friction is 0.50 given in the problem. What is N equal to? N is equal to weight. So if I substitute that in, it becomes mu W. And what is the weight of the traveling car? They give it to you in mass. And we learned that weight is also equal to mass times gravity. So we're going to solve for friction using the generic formula. Friction is equal to mu n. And what is n equal to? N is equal to weight. So mu w. And we said weight is equal to mass times gravity. So I could substitute in mu mg. In the problem, mu is given as 0.50. The mass of the car is given as 750 kilograms. And gravity is 9.8 meters per second squared. So now multiply this out. If you multiply it out, you should get 3,675 newtons. So that is my magnitude. The direction is in the opposite direction. It is going to the west, opposite the motion. Second question asks, what would be the size and direction of the acceleration? So using our fx equation, we're going to plug in. So on C, you want to look for how far. How far is x? So we're going to look for x. We know the car is coming to a stop, so V final has to equal to 0. Before the brakes were applied, it was initially traveling at 30 meters per second. And for part B, we calculated the acceleration as negative 4.9 meters per second squared. Equation with these four variables are Vf squared equals to V naught squared plus 2ax. V final square is equal to 0. So I'm going to rearrange this. Since V naught squared is added to 2ax, opposite of addition is subtraction. So I'm going to subtract V naught squared on both sides. So minus V naught squared, minus V naught squared. These cancel out. So this equation becomes negative V naught squared equals to 2ax. To isolate x, they're all 2a and x are all multiplied. So opposite of that is division. So I'm going to divide both sides by 2a. So we note that the x becomes negative V naught squared over 2a. So if I plug my numbers in, this is negative 30 meters per second. You're going to square that and divide by 2 times negative 4.9 meters per second squared. And if you notice, the negative on top cancels out with the negative on the bottom. If you divide the math out, you should get approximately 91.8 meters. So if you drew your free body diagram correctly, there are 4 forces on this object, on the wooden crate. We have weight going directly down, perpendicular to the earth. Normal is going to be perpendicular to the surface. And then we have a horizontal force. If we have a horizontal force that is constantly used, this will be an applied force, Fa. We're going to assume that the object goes to the right. You can make it go to the left. It doesn't matter. Since we are looking for the sliding coefficient, we know there is friction present in the opposite direction. The other reason we know there is friction or another force is because in order for the object to move at a constant velocity, my net force in the x direction must equal to 0. So if I only have an applied force, my net force cannot equal to 0. So that means friction is opposing the motion because we said the object is moving to the right, and that is my friction. So I'm going to write a sum of Fy and I'm going to write a sum of Fx. As before, In the y direction, there are two vectors, normal and weight. So sum of Fy, we're going to make going up positive is n minus w is equal to ma. Since this object is not moving in the vertical direction, ma is going to equal to 0. And we know that n is equal to w. We're going to write a sum of fx equation. In general, you want to make the direction you're moving positive. Since the object is moving to the right, Fa is going to be positive, and it's going to be opposed by friction, which is moving in an opposite direction. This is also equal to ma. Again, sum of Fy, sum of Fx is the same as net force, remember? And that is always equal to ma. In this problem too, ma is equal to 0 because why? It is moving at a constant velocity. Acceleration can be 0 when it's at rest or moving at a constant velocity. So I'm going to add friction to each side to simplify this math. So this becomes friction is equal to Fa. We also know that friction is mu n. So I'm going to substitute in for friction. So if I substitute in friction, friction is mu n. This is equal to Fa. And what is n equal to? N is equal to w. We solved it in the y direction. So mu is equal to w times Fa. I am solving for mu, so I'm going to divide both sides by w. So mu becomes applied force divided by weight. So applied force here is 30 newtons because that is what you are using to slide it across. The weight of the object is given in kilograms. And we know that weight is also equal to mass times gravity. So that's going to be 12.0 kilograms times 9.8 meters per second squared. Now solve the math. You should get approximately 0.2551. And if you notice, there are no units for mu because weight is in units of newtons and force is in units of newtons, so they cancel out. Pause the video, read the question, write your Fx and Fy equation, and check your answers. So for number 24, if you drew your free body diagram correctly, there are only two forces on the object. So if I have my fish, it is the force of the fish pulling back. This will include its weight. So force fighting back, you could call it FB. And then you have tension going up from the fishing line. So it is up to you if you want to use T or FA, it is up to you. So the first thing I need to do is I need to write a sum of Fy because there is no vectors in the x direction. So again, we're going to do the same thing. Going up, we're going to make positive minus FB. Tension is going up, FB, the force that the fish is fighting back is in the opposite direction. This is equal to mass times acceleration. So the question asks, what is the minimum acceleration? So ma is not going to equal to 0. So my tension from the fishing line is going to be 38 newtons. My force the fish fights back is 40 newtons. Since we're solving for acceleration, I'm going to divide both sides by m to isolate acceleration. So A is going to be T minus FB divided by m. T we just stated is 38 newtons minus 40 newtons divided by the mass of the fish, which is 2.0 kilograms. So if we solve this out, we get approximately -1 meters per second squared. This tells us, since we have a negative answer here, the fish is winning. The acceleration is greater going down than the person pulling the fish up. Pause the video, read the question, draw a free body diagram, and check your answers. So if you drew your picture correctly on the bathroom scale, you will have the weight of the person perpendicular to the earth. You will have normal from the scale. Those are the only two vectors on the scale. Since they're all going in the y direction, we're going to write a generic sum of Fy equation. My sum of Fy, again, my normal is going up. I'm going to make that positive, so it's going to be n minus w, because it's going in the opposite direction. This is equal to ma. So this is my generic equation that I'm going to use for A, B, and C. So on A, it says, as the elevator moves up, this scale reading increases to 935 newtons, then decreases back to 836 newtons. Find the acceleration of the elevator. So that means there's a net force occurring. So the first thing we're going to do is we're going to solve for the mass of the student. To solve for the mass of the student, I use the sum of Fy. So n is minus w is equal to ma. So the mass of the student, or the weight of the student in this case, is given as 836 when the elevator is at rest. When the elevator is at rest, ma has to equal to 0. So n is equal to w. And so that means weight has to equal to 836 newtons. That is the force that is being applied by the scale upward as the person stands and gravity is pulling it down. Since it's not moving, they have to be equal and opposite. We know that weight is equal to mass times gravity. So if I plug that in, this is 836 newtons equals to mass, and gravity is 9.8 meters per second squared. So if I divide this out, the mass of the person is approximately 85.31 kilograms. So now I'm going to solve for A. I'm going to use my formula that I wrote on top, normal minus W equals to ma. In A, my acceleration is not equal to 0 because they want us to find the acceleration. So the scale reading increases. So that's going to be 935 newtons minus 836 newtons equals to the mass, which is 85.31 kilograms, times acceleration. So A has to equal to approximately 1.16 meters per second square. So since the acceleration is positive, it's moving in the upward direction. On part B, we're going to do the same reading. In part B, we're going to use the same equation. So sum of Fy is equal to n minus W equals to ma. We know that the scale reading is 782 newtons. What is the weight of the person? 836 newtons. This is equal to the mass, which we calculated as 85.31 kilograms, times A. Solving for A, we get negative 0.633 meters per second squared. This negative sign here states that the elevator is slowing down. So it's was speeding up. It's trying to stop on the 74th floor, so it needs to slow down. So my acceleration is opposite the speed or velocity in this case. To summarize, to solve for forces, number 1, always draw a correct free body diagram. Do not add additional forces unless it is mentioned. Number 2, write a correct sum of Fy and a sum of Fx. Remember, a sum of Fy and a sum of Fx is the same thing as the net force, which is equal to ma. The reason we have to write Fy and Fx is a force is a vector. Vectors cannot be added unless they are parallel. The other two equations that you need to note is friction is equal to mu n, and then weight is equal to mg, or mass times gravity. In addition, we know that acceleration is only 0 meters per second squared when the object is at rest or moving at a constant velocity. After you draw your free body diagram and write your generic equation, then it is just algebra.